In the last video, you talked a lot about independent and dependent variables. And as a part of that, you realized that independent variables are on the x-axis and dependent variables are on the y-axis. So today, we're going to talk about domain and range, where domain represents x variables. So domain is going to be independent, and range is going to be dependent. So in this particular question, if I zoom out, you can see that it wants to know what is the domain and what is the range. So the domain is all possible x values. Well, what possible x values do I have? Looking at this image, this line here, it's going to go on forever this direction. It's going to go on forever this direction, which means I can pick any x value and there's going to be something there, whether it's below the line or whether it's above the line. I'm always going to have x values. So the way that I'll type that in is I will write the fact that my domain goes from parentheses negative infinity comma to positive infinity. And then I will close it out with the parentheses. In the notation down here, you'll see parentheses are used, or you use brackets. Parentheses are for numbers not included. Brackets are for numbers that are included. And I'll show you kind of how that works in the next example. Our range is representing all of our possible y values. So we've got all these possible y values, and it goes up forever, and it goes down forever. And so I'm always going to have a y value, whether it's to the right or whether it's to the left. I'm always going to have a y value. So my range, similarly, is also from negative infinity to positive infinity. A couple other examples that exist here, or a couple other questions from this question. What's the x-intercept, the y-intercept, and intervals of increase or decrease? Well, my y-intercept is right here at 0, 5. So my y-intercept is at 0, 5. And that is my y-intercept. My x-intercept, it hasn't hit yet, so I'm going to look at a pattern. So I'm going down 1, down 2, over 1, 2, 3. I'll go down 1, down 2, over 1, 2, 3. And I'll be over here at 6, 7, 8, 9. Okay, so if I'm going down 2/3 each time, right, then this is going to go from 6 and 1, and it's going to go down 2/3, and that will get us to this 9, negative 1. And my goal is to figure out where is it actually hitting on the x-axis, And so to help me with that, what I'll do is I'll build a function rule. And I will say, well, I know that y is equal to negative 2/3 x plus 5. And I want my y value to be 0. So 0 equals negative 2/3 x plus 5. And then I can use properties of equality to help me solve this. So I'll use the subtraction property of equality, and I'll subtract 5 from each side. Then I'll have negative 5, simplifying now, equals negative 2/3 x plus 0, because that's an additive identity. I do not need it. So I have negative 5 equals negative 2/3 x. And now I can use the multiplication property of equality to multiply by both sides. I'm going to multiply this side by negative 3 halves, and I'm going to multiply this side here by negative 3 halves. I'll kind of rewrite that so we can see it. Negative 3 halves times negative 2/3 x. Okay, and that equals negative 3 halves times negative 5. So I've just rewritten this whole line. And I'm multiplying fractions. So I turn this negative 5 into a fraction by giving a denominator of 1. And now I can multiply straight across. So I've got negative 3 times negative 5, which is going to be positive 15 divided by 2 times 1, which is going to be 2. And that equals negative 3 times negative 2, which is going to give me positive 6. And I'm going to multiply 2 times 3 on the bottom, which is going to give me a positive 6. And that is x. And so this becomes a multiplicative identity. 6 divided by 6 is the multiplicative identity 1. And 15 divided by 2, you can leave as an improper fraction. Or if you really wanted to write it as a decimal, it would be 7.5. But this is a weird number. And we could tell up here that it was going to turn out to be a weird number because our next slope, 2 and 3, got us down here to 9 and negative 1, not on the x-axis. So 7.5 is our x. And again, 15 over 2 is also an appropriate answer. So either one of these is our x-intercept. On this next picture, you can see that it's a little bit different. You can see on this next picture that there are no arrows, which means it does not continue on. It does not continue on forever. That is not happening. I'm going to erase those. That's not happening. And so what is my domain? Well, I've got these points here. I've got these points, and with these points, I also have lines that connect them. So my domain begins, which is my x values, right? It begins here, and it ends there. So it's going from negative 1 to 2. Is negative 1 included? It is, so I use the bracket. We talked about that in the previous video. And negative 2 is included, so I will use that as a bracket. Now I'm going to check my y's. So my y's go from down here, negative 1, all the way up to 2. And so I will write that the same way. My range is from negative 1 to 2. So this is my range. This is my domain. It wants to know my x and y intercepts. Well, this particular problem is nice because this line hits the x and y axis at the same place right there. That's where it's hitting the y axis. That's where it's hitting the x axis. And so because they're at the same place, my x-intercept is 0. Notice I don't have to do calculations because I can see it. And my y-intercept is 0. Okay? Again, I don't have to do calculations. If I wanted to do calculations, for those of you who are the math nerds and want to see this, they're super excited to see some calculations, it would simply look like this. I build my function rule. I'm going up 1 over 1 each time. And I'm starting at 0. So my function is y equals 1x, which is really just y equals x. So I can say, oh, well, when y equals 0, what does x equal? It equals 0. There's my x-intercept. And when x equals 0, what does y equal? It equals 0. There's my y-intercept. So there's the math behind it for those of you who are a little math nerdy. We've got the range. We've got the domain. We've got the x and y intercepts. And we're ready for the next question. All right. On this last one, we're going to talk about intervals of increase and decrease as well. So let's just go ahead and attack this. I'm going to zoom in a little. It's kind of hard to see, but right here you can see that that's a 2. Okay, and down here you can see that that is an 8. So our y-intercept is 2. Our x-intercept is 8. That's our x-intercept, okay? And next we are going to calculate, we're going to calculate our domain and range. So we're talking about time here in hours. We're talking about distance in miles. How many miles have you traveled? Negative 17 miles. That doesn't happen. That doesn't happen. So our range our range has to start at 0, okay? And then after 0, really, it can go anywhere. It can go to positive infinity. But don't get confused. In our example, the highest our range is 20, okay? That's the highest that our range is. When we talk about domain, can you have negative time? No, that doesn't make sense. So we're beginning at 0. And then after that, time goes on forever, right? But don't get confused. In our particular example, we do not go past 8. That's as much time as we use in our example. So we've gotten that. The last thing that I want to talk about is intervals of increase and decrease. So this interval is going up. This interval is going up. This interval is going up. These green intervals are not increasing or decreasing. They're constant. And these blue intervals are going down. Let's see if I can get that marked. These blue intervals are going down. We have one more green one here. So if I were to ask you, list me all the intervals that are increasing, then I would say, well, this one begins at 0 and it goes to 1. And this one begins at 2 and it goes up until 3. Sorry, I used the wrong symbol there. It needs to be a bracket. And this last one begins at 4 and goes up until 5. So those would be my intervals of increase. Okay. Similar thing with decreasing. Similar thing with intervals of no change, the green ones. Okay. Good luck, guys.